So what do you think the concept of prime means in this setting? What would a prime be?
I guess just a number that doesn't factor into any other primes except it in itself, or it and 1.
Okay. Yeah, and the interesting thing is some of the primes we had before are no longer primes. So let me give you a challenge to see if you can find two Gaussian integers that multiply together to equal 5. So 5 was a prime before.
Yeah, it was.
In the regular integers, but interestingly in the Gaussian integers, 5 is not a prime.
Alright, so this 5 would be over here. With that, could you do, let's see, if you did 2 plus I times 2 minus I, you know the I terms would cancel because you have a plus I and a minus I.
Okay.
And so you'd only be left with real number terms, and then you get 4 plus an I times minus I. Minus I is squared, so minus minus 1 plus 1 equals 5.
Very good. So 5 in the Gaussian integers is no longer a prime, or I shouldn't say that. It's not a prime.
It's not.
5 in the Gaussian integers is not a prime, but interestingly 3 remains a prime, 2 remains a prime.
Yeah.
And so we have a new set of primes, and so in fact in this case 2 plus I and 2 minus I are primes.
Yeah, I guess we need to show that, but I think, yeah, they are prime.
Yeah, we would still have to show it. That's true. It just turns out that they end up being primes. They don't factor any further down at all. And then also 1 plus I is a prime. So why don't you multiply 1 plus I times 2 plus I and see what that number is, because it might be harder to factor that number on its own. 5 we can kind of figure out, but do 1 plus I times 2 plus I.
1 plus I times 2 plus I. So first we multiply 1 by 2, 2 plus 1 times I, so I, plus I times 2, 2I, plus I times I squared, so that would be minus 1.
Okay.
And so we get 1 plus 3I.
Alright. So we get 1 plus 3I. So, is 1 plus 3I prime?
No, because we just showed that those are the two factors, or those are 2 factors of it.
There we go. So 2 plus I, actually we got a little bit of time left, so let's we can draw that, and it starts giving us an interesting picture of what multiplication looks like. So 2, 3, 1, 2, 3. So 1 plus I was here, 2 plus I was here, and they multiplied these two numbers, this number times this number, turned out to be 1 plus 3. It turned out to go up here. So maybe it's not quite obvious how multiplication works yet, but it's interesting to see that this number times this number is this number.
Yeah, it is.
Alright, well, very good. Good work today. So the Gaussian integers are a number system. They have primes. We can multiply and add in them, and then they turn out to be useful for interesting things and help us describe things in an interesting way. And one of the surprises is 5 is not prime in the Gaussian integers.
Yeah.
Alright, good work, Ken.